so I've got Dr. Jones is treating a cardiac patient in intensive care, and he orders 6 milligrams per kilogram of a blood pressure medication. The patient is 5 feet 10 inches tall and weighs 189 pounds. So how many milligrams of the BP medication should be administered? So I've got a couple of distractors here. Cardiac patient, I don't really need to know that for the calculation. Height, I really don't need to know that for the calculation because the order is 6 milligrams per kilogram of the medication. Now, it also tells us that Mr. Jones weighs 189 pounds. So I'm going to start here, 189 pounds, using my factor cancellation method. I'm going to put pounds on the top over 1. I'm going to put pounds on the bottom here over kilograms, because that's the unit that I'm trying to get to, is kilograms. And we know the relationship that 2.2 pounds equals 1 kilogram. So I've got pounds on the top, pounds on the bottom, pounds are going to cancel, and I'm going to multiply 189 across the top, gives me 189 and 2.2 on the bottom. So in order to solve this, then I'm going to say 189 divided by 2.2, and that equals 85.9. And the unit I have left is kilograms, so my unit is kilograms. So the intermediate answer here is 85.9 kilograms. We're still not quite through though. The question is how much of a medication that 6 milligrams per kilogram should be ordered. So now I want to say, although the question states and displays the medication like this, I want to set it up as a fraction. So 6 milligrams per kilogram. And so I've got a relationship established, milligrams per kilogram. And over here, I'm going to have next to it milligrams per kilogram again. And this is the medication ratio. This specific patient is 85.9 kilograms. So then that becomes X. And X then is X, my unknown, in milligrams. So unlike the cancellation factor method where I was multiplying across, now I'm trying to solve for an unknown. I'm trying to solve for X. And the way we do that is we cross multiply. So this times X, and then 6 times 85.9. So I cross multiply, and my answer becomes X equals 515.4. And remember, we said our unknown, the unit is in milligrams. So we know then our unit is in milligrams. So the answer then, this patient should receive 515.4 milligrams of the blood pressure medication. Okay. Now, in the pharmacy, a lot of meds come in a liquid form, and it's not feasible to weigh weigh an amount of meds in a volume 515 milligrams. So we have to figure out, okay, from the pharmacy, the medication comes in a concentration of 40 milligrams per 5 milliliters. So again, I want to carry that relationship, milligram to milliliters, milligram to milliliters, and we know from our previous solution here, we need 515.4 milligrams. So I'm going to say 515.4. So now this becomes my unknown. I'm looking for the volume in milliliters that I need to administer the correct amount to the patient. So X is my unknown, and my unit will be in milliliters. Okay, so now again, we're solving for X, so I need to cross multiply that way and that way. So that gives me 40X equals 515.4 times 5 equals 2577, and I want to get x by itself, so 40x becomes 40 over x, and if I divide this side by 40, I have to divide this side by 40, so that means 2577 divided by 40 equals 64.43 milliliters of the medication. And remember, my unknown was x, and I had already established the relationship milligrams to milliliters, milligrams to milliliters. And I hope that's helpful.